Welcome back, dear students. Let's continue with question number 6 today. So question 6 says, find the volume of wood required to make a closed box of external dimension 80 centimeter, 75 centimeter and 60 centimeter. The thickness of the wall of the box being 2 centimeter throughout. Right. So you need to understand the question very carefully out here. Okay, so there is a closed wooden box. Okay, so let me draw a rough diagram for better understanding. So we have a closed wooden box. Okay, so we have, let's say this is my wooden box. Okay, so this is my wooden box, right, whose external dimension is given. Okay, so external dimension is given to be 80 centimeter, 75 centimeter and 60 centimeter. So this is your 80 centimeter, this is your 75 centimeter, and this height is given to be 60 centimeter. Okay, now what is happening here is, here you have one more, okay, or we can say, since this is a box, okay, it is made up of wood whose measurement, whose thickness is how much? 2 centimeter throughout. So basically I can say that inside this, see, this is the external cube, isn't it? A cuboid, isn't it? Now inside this also we will have a smaller hollow cuboid, isn't it? Okay, all of you, I'm sure you are able to understand what am I trying to say. I'm trying to say that inside this also you will have a small, small cuboid, okay, whose dimension will be somewhat like this. Okay, so this is the rough diagram. Please do not think that this is the original diagram, right? Okay, and you know that this red colored one will be the hollow cuboid. Outside we will have the solid cuboid, and inside this cuboid will be hollow, isn't it? Now it is given that the thickness of the wood is 2 centimeter, isn't it? So that means it here this, okay, so this thickness is 2 centimeter. Similarly from top also, since it is closed, so from top also it is 2 centimeter. Okay, now if I ask you what will be the dimension of inner one, so what do you need to do? Let's see. So we will first, so we have two cuboid, as I said. Okay, so we have outer cuboid, so we will write outer cuboid, and we have got inner cuboid. Okay, so we have inner cuboid. Now for outer cuboid, what are the things given? For outer cuboid, your length is given to be 80 centimeter, breadth is given to be 75 centimeter, and your height is given to be 60 centimeter, right? Now for inner cuboid, let's find what's length, breadth and height. Okay, so let's talk about length. Now all of you know this gives you the length. Now from here to here is 80. So from 80 we will remove this thickness and we will remove this thickness. We have got two walls, isn't it? So if you remove this thickness, you will get length of the inner cuboid. So basically, see, outside we have 80, right? So from 80 we have to remove this thickness, which is 2 centimeter, and this thickness, which is 2 centimeter. So when you subtract, how much do you get? 80 minus 2 is 78, 78 minus 2 is 76 centimeter. Okay, similarly breadth will also be the same. So originally your breadth is given to be 75, right? So breadth is given to be 75, but here also you need to subtract 2 centimeter and 2 centimeter. There are two walls, so that's why you need to subtract 2 times. Okay, so when you subtract, you get 71 centimeter, and similarly height is going to be 60 minus 2 minus 2, which is going to be 70. This is 56 centimeter. Okay, now in order to find, the question is saying find the volume of the wood required to make. Okay, so therefore volume of the wood in the box. So for calculating the volume of the wood in the box, we have to make use of this particular formula. Kindly look at this very carefully. So it is volume of outer cuboid minus volume of inner cuboid. Okay, so this is how we need to, or this is the formula for calculating volume of the wood in the box. Now volume of outer cuboid, it is L into B into H. Now for outer cuboid, L into B into H will be 80 into 75 into 60 minus volume of inner cuboid. Now for inner cuboid, length is 76, breadth is 71 and height is 56. Okay, so you just need to calculate this. So let's calculate quickly. So 80 into 75 into 60 will be this much. Okay, minus, so we have 76 into 71 into 56. So when you calculate this, this will be 302176. Now you just find the difference, you get your answer. Okay, so we have to find the difference out here, right? So the difference turns out to be exactly 57,824, and since this is the volume, your unit is going to be centimeter cube. So you may pause the video and note down your solution. Let's have a look at the next question. So next question on the screen says, a closed box measures 66 centimeter, 36 centimeter and 21 centimeter from outside. A similar kind of question. If its walls are made up of metal sheet 0.5 centimeter thick, find the capacity of the box. Okay, so question is asking you what is the volume of the box. See, remember, it's different. Okay, capacity of the box means how much is the storage. Okay, and next is find the volume of the metal sheet. So the second part we have already seen in the earlier question. Okay, so there is no problem with the second part. Third part says weight of the box if 1 centimeter cube of metal weighs 3.6 grams. So this is also easy question. So there are I can say there are two cuboid. Okay, so outer cuboid and inner cuboid. Okay, so we have outer cuboid, right? So we have outer cuboid and we have inner cuboid. So two cuboids are there, remember. So for outer cuboid, length is given to be 66 centimeter, breadth is given to be 36 centimeter and height is given to be 21 centimeter. Okay, for inner cuboid, since it is closed, so that's why all of you know it will be 66 minus, we have to subtract the thickness, which is 0.5, but we have to subtract 2 times, isn't it? So when you subtract, you get 65 centimeter. Breadth is going to be 36 minus 0.5 minus 0.5, that is 35 centimeter, and the height is going to be 21 minus 0.5 minus 0.5, which is 20 centimeter. So I got the dimension of inner cuboid. Okay, now for finding number one, the capacity. Okay, so to find the capacity of the box, we have to use formula for volume only, that is L into B into H. Now which L should I use? Should I use this one or should I use this one? Now since the capacity of the box is calculated with respect to the inner dimension, so that's why I need to make use of this L, this B and this H. Okay, so that's why you get your answer to be 65 into 35 into 20, right? So when you calculate this, okay, so let me quickly calculate this. This is 65 into 35 into 65 into 35 into 20 will be equals to 45,500. 45,500 will be the this much centimeter cube will be the capacity of the box. Okay, number 2, you have to find what is the volume of metal sheet. Volume of metal sheet. Okay, so volume of metal sheet, as I already told you, you have to do this. So first find what is the volume of earlier one, okay, and subtract the volume of second one. Now volume of second one will be, all of you know, it is 65 into 35 into 20, isn't it? Now all of you know, when you multiply this, you get 45,500. Now let's multiply this and check. 66 into 36 into 21 will be 49,500. 49,896. Okay, so when you find the difference, you get your answer to 4,396 centimeter cube. So this will be the volume of metal sheet. Okay, so we are left with the last part, number 3. Let me do the number 3 out here. So in number 3, you have to find weight of the box if 1 centimeter cube weighs this much. Okay, so weight of given is weight of 1 centimeter cube of metal. So it is given to be equals to 3.6 grams, isn't it? Now what is the actual volume of metal sheet? It is this much, isn't it? So therefore weight of the box will be equals to, so weight of 1 centimeter cube is 3.6, whereas we have got 4,396 centimeter cube of metal in the box. So that's why we'll multiply with this, and when you multiply this 2, you get your answer to be, see here carefully, you get 15,825.6 grams, and if you convert this into kilograms, it will be 15.8256 kilogram. Okay, so this will be the weight of the box. All right, so you may pause the video and note down your solution. Let's move to the next question, and this is going to be my last question for the day. Question says, a tank 30 meter long, 20 meter wide and 4.5 meter deep is to be made. It is open from the top. Now this is very important, everyone. This part is very important. As of now, we were dealing with the closed box, but this time the tank is open from the top. Now find the cost of iron sheet required at the rate of 65 per meter square to make the tank. Okay, see here carefully. You have to find what? You have to find the cost of iron sheet required at the rate of rupees 65 per meter square. So per meter square, they are talking about area. So if they are talking about area, you need to find total surface area in this case, because you know in all the surfaces it is made up of iron sheet, isn't it? So that's why we need to find total surface area of the open tank. Okay, so for the tank, it is given that length is given to be 30 meter, breadth is given to be, that breadth is the width is given to be 24 meter, and height is the depth, right? So height is given to be 4.5 meter. Okay, now you remember I have given you formula for calculating total surface area of the roof, 4 walls, isn't it? So along with the 4 wall, okay, so we will find total surface area. So total surface area will be equals to area of the 4 wall plus we need to add area of the floor, isn't it? Area of the floor. Okay, now see here carefully, don't get confused. So if this is a diagram for you, all of you are quite aware that you call this to be L, you call this to be B, and you call this to be H. Okay, now all of you know that area of the floor wall is 2 into L plus B into H. So this is the area of the floor wall. Now area of the floor, now floor will be in rectangular shape, all of you know. Now what will the area of this this floor? It will be L into B, isn't it? So it will be L into B, right? So now let's put the value. So 2 into L is 30 plus B is 24 into H is 4.5 plus L is 30 into B is again 24, right? So let's quickly calculate this. So this is going to be, I'm going to write directly the final answer. Okay, so when you simplify this, you get 486 plus you have 30 into 24 will be equal to 720. Okay, so you just add them up. So when you add these two, you get 1206 meters square. So this is the area, total surface area, that is area of iron sheet that is used. Okay, so therefore cost of iron sheet, that's what we need to find at last, isn't it? So therefore cost of iron sheet required. Okay, so this will be equals to, now for 1 meter square, per meter square means it is 1 meter square. For 1 meter square you need to pay rupees 65, but we have got 1206 meter square, so that's why we will multiply 65 with 1206 in order to get your answer. Okay, so when you multiply with 65 you get rupees 78,390 to be the answer, right? So you may pause the video and note down your solution, and with this we close exercise 21B here. Okay, thank you very much.